Yep, so my name's Ian Robinson. I'm a specialist solutions architect for data and analytics at Amazon Web Services. So this afternoon, I'm going to be talking about the kinds of big data and analytics architectures that you can implement using our services, in particular some of our managed and serverless analytics services. So we're going to look at ingest and storage, data preparation, processing, analysis, visualization, and so on. And if we have time, we'll also look at, very briefly perhaps at some of the ML and the AI services that we offer as well. And all of that in the context of your developing a comprehensive data and analytics platform. So I want to start just by summarizing some of the forces and some of the trends that we see that are prompting customers to bring many of their analytics workloads over to the cloud. So on the one hand, we have the need to get out of the data center, to reduce those procurement life cycles and those very, very long hardware refresh cycles, and potentially to escape from some very punitive licensing lock-in. These are some of the motivations for coming over to the cloud. On the other hand, we have this desire to create a more agile analytics capability. Customers want to be able to experiment. They want to be able to take a data set and to go from idea to insight far more quickly than they have done in the past. Instead of it taking weeks or months, they want to be able to do this in minutes or hours. And if some of those experiments are successful, we want to move that as quickly as possible into production without having to re-engineer or re-architect the solution. And if that experiment looks as though it's failing, if we're not learning anything from it or not learning anything more from that experiment, then we want the ability to be able to terminate it and to stop paying for any of the resources that we might be consuming. So this is just a fraction of the forces and the trends that we're seeing that influence customers and prompt them very often to bring some of their analytics workloads over to the cloud. Now, one of the things that we've noticed over the last few years, and this is whether you're on-premise or in the cloud, but one of the things that we've noticed is that data has gravity. Your data will often outlive the tools and the applications that you use to acquire it, to process it, to analyze it, to visualize it. So applications come and go. This year's popular tool may be next year's legacy. But the data itself has this kind of geologic lifespan. It outlives all of those applications. So ideally, what we want to be able to build today with any kind of modern data architecture is a platform that allows us to store all of our data forever at every stage of its life cycle. And then to choose the right tool for the job, to apply it using the correct service or technology for the specific use case at hand. And one of the wonderful things about cloud is that it has more properly allowed us to separate these very, very different concerns, to separate storage from compute. And we can provision and scale storage quite independently today from the ways in which we provision and scale compute resources. Okay, so this plays very nicely in our desire for an agile analytics platform, the ability to store all our data forever at every stage of its life cycle, and then apply it using the most appropriate tool at hand. So if we're going to follow this line of reasoning, then we'd say effectively, storage for us is job number one. It's a foundational capability for any other analytics capabilities we would want to build on top of it. So within AWS, we have many, many different storage options. And even here, it's a matter of choosing the right tool for the job. If you're dealing with a file system-based app, then you probably want the Elastic File System. If you need local block storage for your virtual machines, then you choose EBS. If you've got online transactional use cases, then you might choose a managed relational database, or you might choose something like DynamoDB, our own managed NoSQL database. But for analytics, there's one service above all that really is foundational. Object storage is foundational. And for us, that is S3. S3 is our simple storage service, one of the oldest services that we run. It's been around for nearly 10 years. Okay. So S3 gives us near infinite storage capacity. It allows us to put objects to the object store and to retrieve them. They can be small objects, they can be large objects up to 5 terabytes in size. We don't have to think up front about provisioning any capacity. S3 will just accept as many objects as you care to throw at it. And every object that's written to S3 is immediately copied to at least 3 physical facilities, which means that we're guaranteeing effectively 11 nines of durability. So we're providing this near infinitely scalable, highly durable, highly available, very cheap, very secure object storage. And you can think of it in many ways, certainly in analytics terms, you can think of it in many ways as being managed HDFS, where you don't have to worry about provisioning capacity or maintaining redundancy. We'll do all of that on your behalf. And in fact, for many of our analytics technologies, a lot of the stuff that's built on top of EMR, our managed Hadoop stack, things like Presto or Spark or Hive, can treat S3 as though it were HDFS. We have a component that we install in those environments that will actually present S3 as though it were HDFS. Okay. But S3 isn't just DOM storage. It also has events and lifecycle management built in as well. So every time we store or write an object to S3, we can treat that as an event. If ever we modify an object or delete it, again, we can treat that as an event. And we can attach event handlers. We can attach Lambda functions, code that you write, you upload to AWS, and then we'll be responsible for provisioning the compute infrastructure that will run that code whenever it's triggered by one of those events. So if you've got a batch ingest mechanism that's periodically putting objects into S3, every time we receive one of those objects, we could trigger some other activity. We could use a Lambda function to trigger some other downstream activity. And that may be that it kicks off some ETL work, or it kicks off some analysis, some automated analysis on your behalf. So that's the eventing mechanism that's built into S3, and that makes for a very powerful, very simple way of building out data-driven pipelines. But besides that, we also have lifecycle management. Effectively, we have tiered storage within S3. So typically, you'll put objects into standard storage where you can retrieve them very frequently, very often, where the time to first byte is typically sub 100 milliseconds. But you can also attach lifecycle policies to those objects or to collections of objects so that after a period of time, we remove them from S3 or we move them into a different storage tier. We have a tier called Glacier, which effectively provides for managed archiving of all of your data. And that's an even cheaper storage medium. The time to retrieve those objects can often be in the order of hours or days, but it provides exactly the same levels of durability, 11 nines of durability for your items. So if you find that you're putting objects into S3 and you need frequently to access them, perhaps for the first 30 days, that's great. But if after that all you need to do is archive them, perhaps for some kind of regulatory or auditing purposes, then you might attach a lifecycle policy and automatically have those objects pushed into Glacier. So S3 for us, and for many years, has been effectively the foundation of some kind of data lake-like architecture. Near infinite storage capacity, no need to do any capacity planning up front, no need to think up front about any particular storage formats, extremely high levels of durability and availability, the ability to secure that data on a per object or per collection basis, the ability to be able to encrypt it. All of these are effectively provided out of the box with S3. And as I say, on top of that, we provide native integration to many applications that run in the Hadoop ecosystem. So Presto, Spark, Hive, and so on, can all treat S3 as though it were HDFS. And this gives us a very, very powerful ability to have multiple clusters, multiple applications, all pointed at the same underlying data set. We can treat S3 as the durable storage, and then quite independently, we can provision and spin up compute resources that will do something interesting to that data, perhaps calculate some aggregations, perhaps transform it, but put the results back to S3, and then we can turn off those compute resources. So if you're familiar with running large, long-lived Hadoop environments on-premise, where you're kind of coupling the responsibility for storage and compute, well, the model in the cloud can be very, very different. You can treat S3 as the long-lived, durable storage layer, And then you can spin up Hadoop environments and applications as needed in order to do those compute-intensive tasks and then turn them off. So that's the underlying storage layer for many big data and analytics architectures that we see customers building in AWS. Now, there are lots of different ways of getting data into S3. We have S3 APIs, we have the S3 upload APIs, we have a transfer acceleration service, so you have very, very large objects which you are uploading very frequently into S3. Then you might use the transfer acceleration service, which means that you will upload simply to a local or near endpoint, and then we will use the underlying AWS backbone in order to transfer that into S3. So we can reduce the latencies, reduce any jitter around using the public internet in order to transfer very, very large objects. If you have large bulk uploads, perhaps a one-off upload of many tens of terabytes, then we have things like Snowball, which is a ruggedized device which you can install in your data center, copy over up to 100 terabytes of data today, and then that device is shipped to AWS, to the specific region where you want to place your data, and we will put that data onto S3 for you. And that's often, for many, many tens of terabytes of data, that is often the fastest way of getting that data into AWS in the first place. So that's for kind of batch and large object upload. But there are a couple of other ways of getting data into S3. It may be that you have streaming requirements. You've got very high throughput streaming applications, perhaps mobile devices, or IoT devices, web apps, and so on, where you're generating lots and lots of streaming data, but you want to ingest that into your data lake. You may very well want to do some streaming analytics on top of it, and we can talk about that later on, but you may also want to preserve that data, perhaps in its raw form, so that you can join it with other sources of data within that data lake environment. And so for streaming ingest and delivering that data into S3, we have Kinesis Firehose. So we have a family of products called Kinesis. Kinesis Streams, Kinesis Firehose, Kinesis Analytics. Kinesis Firehose is simply a kind of delivery mechanism. It allows streaming producers to put events into the Firehose. The Firehose will buffer those events, typically for a minute or so, or up to a certain size, and you can configure all of that. But then periodically, the Firehose will emit a batch of events into a target. And that target can be S3, it can be Redshift, which is a managed data warehousing environment, or it could be our managed version of Elasticsearch. So streaming, high throughput streaming events produced by many, many different producers and clients out there in the wild, and then we're buffering and emitting those events into a target system on a periodic basis. And again, you don't have to think about managing any infrastructure here. You simply provision a Firehose delivery stream, and we'll take care of scaling it on your behalf and operating it on your behalf. Similarly, if you have relational databases on-premise, we have services that will enable you to bring that data over into AWS. We have something called the Database Migration Service. And this will allow you to take a relational database on-premise and migrate it to a relational target in AWS. That might be something within our managed relational database service. So we have managed Oracle, SQL Server, Postgres, MySQL, Aurora DB. We have our own Amazon relational database called Aurora. So you can bring data over from relational source on-premise and migrate it into one of those targets. And you can do that as a one-off activity, but you can also enable change data capture, so you can effectively do streaming change data capture into those targets in AWS. But besides having a relational target in AWS, you can also treat S3 again as a target for the database migration service. So it may be that you do a one-off batch migration into S3 of the underlying data on a table-by-table basis, and then you would enable the change data capture, and again, periodically, we will emit a batch of change records into S3, time-stamped, compressed, and available for you to analyze them, join them, process them using some other technology. So far, we've really been talking about foundational storage, this ability to acquire, store all your data forever at every stage of its life cycle. But what you'll find is if you're just throwing all your data into S3, there's the danger that it simply becomes a data swamp. So we're finding more and more customers require a high degree of governance around their data. So besides having this near infinitely scalable storage medium that we manage, and besides adopting a practice of effectively putting immutable data sets to that storage medium, every time you compute something over a data set, the results of that is a new data set that you'll put to S3. Besides all of that, there's also a need for versioned schema and metadata that describes all of those sources of data within your AWS estate, that allows you to find sources of data that you may subsequently want to do some analysis on. If you can combine those three different characteristics, those three different features, then effectively we have the basis for data discovery and data lineage and data governance. And there's a service here that helps enormously in that respect, and that's a service called AWS GLue. Okay. So we announced this last year, we released it earlier this year. GLue has three fundamental capabilities. On the one hand, it provides a data catalog, and that's what I'm going to talk about in a moment. And then a bit later, I'll talk about the other two features of GLue, which are managed or serverless ETL and the ability to be able to schedule and execute those transform jobs. So GLue provides you with a data catalog, with a highly available Hive Metastore compatible metadata repository that scans your entire account or runs across your entire account. So here you can upload metadata describing all the sources of data within your AWS estate. And that could be sources of data that reside in S3, but it could also be sources of data sitting in a relational service or within a data warehouse. Now, on top of the standard Hive APIs, we've included our own search APIs. We've included the ability for you to be able to tag the metadata at the table level. But importantly, we've also included this concept of crawlers, the ability for you to be able to provision a crawler that will go looking for new sources of data within your estate. And it can do that on a periodic basis. And when it finds new sources of data, that crawler can automatically infer the schema for the data that it finds and then upload that metadata into the repository. So you can populate the data catalog using Hive DDL, and there's a batch or bulk import mechanism, but there's also this automated mechanism of using crawlers to discover sources of data, and that can be data in S3, but it can also be data at the end of a JDBC connection, for example, and to automatically upload that metadata into the catalog. And then those external table definitions are immediately available for being consumed by GLue as a managed ETL service, but they're also available for being consumed by all the stuff that's running on EMR, so things like Spark, Hive, Presto, and so on. They can all use those external table definitions. And as we'll see a bit later on, there are a few other services that we have, including things like Athena, which allow you to write SQL directly against your data in S3, that again can use those external table definitions. So one table definition, but suddenly you can consume or process that data using a multiple different technologies according to the need at hand. So this slide just talks in a bit more detail about those crawlers. The ability for you to be able to provision a crawler, and then when that crawler executes, and you specify the schedule on which that crawler executes, but when it does, it will go crawling the specific portion of AWS that you've specified. It may be a portion of the S3 key space, and if it finds new objects, new sources of data, the crawler will attempt to apply a classifier to determine whether it understands the data format. And we recognize lots and lots of different formats out of the box, lots of text-based formats, CSV, TSV, but also Avro, JSON, ORC, Parquet. If the crawler understands that file format, then it will scan the data, and again, it can do this to compressed file formats as well, but it will try and attempt to infer the schema and then upload that metadata into the catalog. Now, if you schedule a crawler to run repeatedly, perhaps on a scheduled basis, once a week or once a day, If the second time round that crawler discovers a new source of data in the same location, it will try and determine whether that new source of data has ostensibly the same schema or a similar schema to what it's discovered previously. If there are some differences, perhaps it's JSON data and you've added a column or slightly modified the document structure. But if the crawler believes it's similar enough, then it will version the metadata in the catalog. So effectively, we're providing for versioned metadata within Glue's data catalog. And then on top of the data catalog, we also provide abilities hooking into those kind of S3 events, for example. Every time a new object lands in S3, we can hook into that using a Lambda function, and we can populate additional metadata or search criteria in DynamoDB, in our key value store, or in our managed Elasticsearch service. So between these three sources, Dynamo, Elasticsearch, and the data catalog, we have a very powerful data discovery and governance mechanism. Okay. So we said that effectively storage is foundational. It's job number one. But for us, actually, security is job zero. It is the most fundamental activity that we're going to pursue here. And again, within AWS, we have some very, very comprehensive security and auditing capabilities. So we have things like identity and access management and federated identity, and we have comprehensive logging of all API activities, all access to every object that resides in S3, and every call into every other API that controls every other service in AWS. We can log that, we can alert on it, and we can give you the ability to be able to query and analyze against all of that log data. So top and tail, we provide for very comprehensive securing of the data and auditing and logging. The foundation for all of that security is identity and access management. So with IAM, you can create users and groups and roles. And then for every other service in AWS, you can specify which users, which groups, which roles can access that API or access specific operations within that API. You can effectively determine who can access that service and what they can do with regard to that service. So we're effectively securing the data at the storage layer itself. When you put data into S3, you put data into buckets, okay? And it's effectively a key value model. You provide a key, which might look like a URL, might look like a directory structure. The value is the object itself, is the binary object or the text-based object that you're putting into S3. The buckets themselves, you can attach security policies to them. So you can use this IAM mechanism to specify who is entitled to put objects into a bucket, who can list the objects, and who can access them or modify them. Right? So we're securing every object within S3 at the lowest possible layer. And similarly, across the breadth of other services that we offer, again, we're using the very same security mechanism, identity and access management, to secure access to all of those APIs, all of the ways in which you can access and manipulate data. And then on top of that, you can layer other security mechanisms. So it may be that you want row-level access within some of, with things like Hive. Well, that's very easily done if you use something like Apache Ranger. These slides will be available after the talk. This short URI points to a blog article which describes how you can install Ranger within AWS in order to control access, produce effectively row-based access to all of those objects or to all of the data that resides in S3. And similarly, as I said, with things like CloudTrail, we're effectively logging every single API call. If we put that into S3, again, you can use tools like Athena, and we'll talk about that a little later, but you can use tools like Athena to query over those logs in order to identify who's been accessing the data and what it is that they've been doing to it. We also provide for very, very comprehensive encryption of data at rest and in transit. There's some very simple encryption mechanisms where you pretty much leave it to us to manage it on your behalf. That's the server-side encryption, where we manage the keys and we'll encrypt the data automatically and decrypt it when the clients access it. If you want to manage the keys themselves, rotate them and so on, then you can use our own key management service. If you prefer dedicated hardware that resides within our data centers, then you can use the cloud HSM. And in fact, we also provide mechanisms for integrating with hardware security devices back on premise as well. So there's a comprehensive range of options for you to be able to secure your data at rest and in transit for all of these applications. All right, so storage has been foundational, and then we've talked very briefly about some of the ways in which we secure that storage. What I'm briefly going to go through now are several different ways in which you can choose to apply that data. Now, we may do that using compute resources that you provision and manage within AWS. And we have things like EMR, our own managed Hadoop environment, that would allow you to provision those resources, to install applications from our distribution on it. But you become responsible at that point for choosing how to size those resources. You become responsible for spinning them up and deciding when to turn them off. But we also have a range of serverless technologies where you don't even have to think about the infrastructure. So in terms of things like ETL, for doing some data preparation, for some transformation, we can take advantage of two of those other capabilities in GLue. So GLue allows you to define transformations. Given a source and a target from the data catalog, create for me a transformation that will take data from the source, transform it, and push it into the target. Behind the scenes, we'll create for you some Python code that addresses Spark, PySpark code. Now you can open that code in your own IDE in the browser and further modify it, further enrich the data. And in fact, you can also bring your own code. You don't have to take the auto-generated code that GLue provides for you. You can bring your own PySpark code to GLue, sit it in S3, and then GLue can execute it on your behalf. So behind the scenes, GLue is using Spark, but it's using it on compute resources that we provision and manage on your behalf. You don't have to think about any of that. Besides defining the transformations, you can also define the schedules. Again, it could be a periodic schedule, or it could be event-based. It could be that whenever new objects arrive in S3, you want to trigger a specific job. The successful completion of a job or the failure of a job in and of itself is an event that we can use to trigger another job. So we can build dependency trees of jobs. So again, this is providing you the ability to be able to create transformations, schedule them, and stick them together as part of a data-driven pipeline. Having prepared your data, and one of the things that you might use GLue for is, well, you're landing your data in its raw form, perhaps it's compressed CSV or JSON, but you want to transform it into a query-optimized format like Parquet or ORC. Well, that's something that GLue is great for. You know, with just a couple of lines, a couple of calls into the API or a couple of lines of code, we can do that in GLue without having to spin up any infrastructure. Having converted that data into a query-optimized format, we can use something like Kinesis Analytics is the streaming analytics technology. Okay, so I'll talk about Athena in a moment and the stuff. So Kinesis Analytics allows us to write SQL over streaming data. So data that's coming in on that Kinesis Firehose or data that's coming in on a Kinesis stream, we can create a Kinesis Analytics application that will allow us to write SQL over that streaming data. So effectively streaming analytics. Kinesis Analytics also includes some, it's kind of ANSI SQL compliant, but we've included some additional functions, and we're expanding the range of those functions that allow you to do things such as anomaly detection within a stream. So we can establish a baseline of, this is what normal looks like as far as our streaming data is concerned, and then that function can then begin to identify events that look anomalous and can provide you with the reasoning behind why it thinks that event is anomalous. Which data points did it observe that it thought presented some kind of anomalous event? So here's some SQL that we might write over a stream. If we're ingesting events from Twitter, then we might write some SQL over that, looking for over a 1-minute window, as it were. And I think what we're doing here is just aggregating those events by author over a 1-minute tumbling window. So very easy to write that SQL over that streaming data. If we want to analyze the data at rest, once we've actually landed it in S3, and we don't want to have to then bring that data somewhere else, into any other compute environment, then we can use something like Athena. This is our managed interactive queries against data at rest in S3. So perhaps we've converted to Parquet or ORC. We've got those external table definitions in the GLue data catalog. The moment we've got all of that, we can use Athena to start writing SQL against that data. No need to bring it into some other compute environment. No need to spin up anything on a managed Hadoop environment, we just use Athena to write queries directly against that data. So Athena presents you with a JDBC endpoint, but there's also a SQL client-like browser experience where we can write our SQL. So you see that at the top right. We see the results on the bottom right there. And on the left-hand side, we have another view into that data catalog. So Athena, where Athena and GLue are both present within a specific region, Athena will share its data catalog with GLue. So remember, one table definition in GLUE's data catalog can be consumed from a number of different technologies, including Athena. And then in terms of visualization, we offer another managed service, which is QuickSight. Allows you to create browser-based dashboards, charts, and to share those within your organization. And this allows you to connect to sources of data within your AWS estate and to effectively create BI and visualization dashboards on top of that data. QuickSight actually has an Athena connector which will delegate to Athena in order to run very, very large computations or aggregations over very large data sets in S3. So Athena is great for effectively writing SQL over petabytes of data sitting at rest in S3. If we want to compute some aggregations and visualize that in QuickSight, then we might use QuickSight together with the Athena connector pointed at the data that's sitting in S3. And here's an example of the kinds of dashboards that we can create. The goal here with QuickSight is effectively to get you up and running, again, without having to install any infrastructure, without having to install any servers, but to get you creating your first dashboard within 5 minutes of having first logged into the service. Okay. So I'll wrap up very, very briefly. We've looked at some of the mechanisms that we have for ingesting and storing data. I've said that S3 is effectively our foundational storage layer for data lake-like scenarios where we can store all our data forever at every stage of its life cycle. And then we can pick and choose between a very, very wide variety of applications in order to process and analyze that data. We've looked at Kinesis analytics for serverless SQL over streaming data. We looked very briefly at Athena for writing SQL over that data at rest in S3. I've kind of flicked forward through the AI and ML, but we can see over here on the right-hand side, just a subset of some of the capabilities that we have in AWS for applying and processing and analyzing that data. All right, that pretty much wraps it all up. So hopefully that was useful, gave you an end-to-end sense of what's going on. So thank you very much.